everybody? The fluid pressure or liquid pressure or gaseous pressure formula is rho GH, means density of the fluid into acceleration due to gravity into height of the liquid. Please note it, or height of the fluid. Please write it. Very, very important. Okay. So rho GH, density, sorry, fluid pressure. Yes, please. The pressure exerted by a fluid is equals to density into acceleration due to gravity, acceleration due to gravity into, what is that, guys? Height of the liquid. Clear, everybody? Height of the, yes, please, liquid. Okay. So these are the three, that is the formula for liquid pressure or the gaseous pressure. So solid pressure means, what is the formula, everybody? Pressure exerted by solids, force by area. Pressure exerted by fluids, rho GH. What do you mean by rho, everybody? Gokul? Density. Understand? And what do you mean by G? Acceleration due to gravity. What do you mean by H? Height of the liquid, height of the column, liquid column. Please remember. Okay. Any doubt? Anybody can ask me. Derivation understood, everybody? Is it easy or tough? Yes or no? Mr. Sam?
Yes, sir.
Yeah. Any doubt? Mr. Lingesh, Hasini, Sudhakar, are you clear? Danishka, Prithvi? No response at all. So just very simple.
Yes, sir.
Mind how to use it. If any doubt anybody having, you can ask me. So this is the most important one. You can calculate the pressure exerted by any liquid. Even you can calculate the pressure exerted by your water tank, which is present above your house. So anything you can calculate by using this. But now we have to verify the units. What is the pressure units, everybody? What is the pressure units? Anybody?
Pascal.
Pascal. Okay. What amma? Yeah. So what is the unit of pressure, everybody? Units of pressure, please. Units of pressure. Units of pressure is Pascal. So 1 Pascal is equals to what, Nivedan? 1 Pascal is equals to 1 Newton into 1 meter square. Am I right or wrong? Yes, please.
Yes, sir.
Yeah. Now we have to verify. Of course, that I will send you guys. You don't worry. So now we have to verify the units. So units verification is very, very important. So let us verify the units now. Is it right or wrong? So we know pressure is equals to force by area. Force by area. So what is the unit of force, everybody? Unit of force, Newton. Unit of area, square meter. Square meters. So that we are getting 1 Newton per square meter, which is equals to how many pascals? Everybody? 1 Pascal. Okay, we got it. But what about the fluid pressure? Fluid pressure. Let us verify. What is the formula for fluid pressure, everybody? Make attention. What is the formula for fluid pressure? Yes. Rho into G into H. Okay, wow. Rho GH. Okay. So now just please make attention. Little tough. So density. What is the unit of density? First, tell me what is the unit formula for density? Density is equals to volume. Density is equals to what? All of you?
Mass by volume.
Mass by volume.
Yes. Mass by volume. So what is the unit of mass? Unit of mass, kilogram. Unit of volume, cubic meter. Unit of volume is what? Everyone? Shivani? Agalya? Unit of mass. What is that? Who is that nonsense? Gokul, make attention. Next. So now, density unit. What is the unit of density? Everybody, make it quick, guys. Kilogram per cubic meter. Into. What is the unit of G? Everybody, acceleration or G, both units. Ellame theriyum. Meter per second square. Meter per second square into. What is the unit of H? Height. Unit of H. Height. Height ra meters. Understand? Meters. Now, here the common mistake which you people will do, I will teach you, but that is not the way you have to solve the units. Finally, we have to get it what? Newton per square meter, which is equals to evala Pascal. Everybody, 1 Pascal. Okay. Now, basically, we people will do what mistake you can see. Can I get cancel now? Meter and here 1 meter get cancelled. Here 1 meter and another meter will get cancelled. What is the remaining unit? Kilogram per meter second square. Am I right, Mari? Engage?
Yes, sir.
Yes. But is it equals to Pascal? Is it equals to Pascal?
No,
Tell me.
sir.
No. So your unit is wrong. You are not supposed to cancel like this. Now I will teach you, see, how to solve. So this is entirely wrong. How to solve it is very important. Everybody will think similar things get cancelled. So now, kilogram divided by cubic meter into meter per second square into meter. Okay, let it be like this. Now you tell me 1 Newton means we are studying from long back. 1 Newton means we can do something. F is equals to MA. So mass means kilogram. A means meter per second square. So 1 Newton means what I can write? Anybody can tell?
kg meter per second.
Yes, kilogram meter per second square. That is I have to do it. Inga paakranga ellame. Kilogram meter per second square, which is equals to what? Anybody? That whole thing I'll replace it to what? Speak loudly. Newton.
Newton.
Meter divided by meter cube. Any problem, Mari? Here meter cube is there, here meter is there. Okay, wow. Ellame.
Yes.
Yes. Now this meter and 1 meter will get cancelled. Here remaining what? 2. So what else remaining? Newton
by meter square.
Newton per square meter, which is equals how many pascals, Agalya? Shivani?
Pascal.
1 Pascal.
1
Answer,
Pascal.
Mariamma? Understand? Agalya? Clear? Shivani?
Yes, sir.
So,
Yes, sir.
the way you have to solve is very, very important. So, you have to be, you cannot cancel it like this. So, you have to be very smart in this. So, finally, units are saved. Niroshi, understand, Niroshi?
Yes, sir.
Sam, any doubt you can ask me. Clear, everybody? Mukesh?
Yes,
That
sir.
is the unit of Pascal. So, whatever it is, what is the unit of pressure? Pascal only. Either it is a liquid pressure or it is a solid pressure, doesn't matter. Always unit of pressure is what? Pascal. Clear, Mr. Sam? Any doubt, Sam? Okay. All of you. Yes?
Yes, sir.
Do it. No issues. Now, this pressure is depends on 3 factors. That is the 3 things. So please learn it. Very, very important. What is that? The height of the liquid column above the point, the density of the liquid, acceleration due to gravity of the liquid. Because liquid pressure or fluid pressure is equals to rho GH. So it is depends on 2 factors. Liquid pressure is directly proportional to density of liquid. So if density increases, then fluid pressure also. Everybody, fluid pressure also increases. If height of the column increases, then fluid pressure is also. Everybody. Yes, please.
Increases.
Fluid pressure also increases. Next, suppose same fluid I will put it on the moon. Same fluid I will put it on the earth. Where they will exert more pressure? Moon, earth. Where they will exert more pressure? Everybody. Earth, moon. Pressure. Earth. Because earth gravity is greater than moon gravity. Am I right or wrong? Everybody, please respond. So,
Yes.
that is why G value increases. Acceleration also what? Sorry, fluid pressure also what? Increases. Purima ma. Clear, everybody? Yes, please. All of you. So moon's gravity is just 1.63. Earth gravity is how much? 9.8 meter per second square. So that is the reason gravity, acceleration due to gravity at that place. At that given place, what is the G value will decides the pressure exerted by liquids. I hope you all understand. So these are the three factors which will affect the pressure exerted by fluids. Any doubt for anybody, you can ask me, or else you can write it. Understand, Hasini, Sudhaka, Lingesh, Mukesh? Any problem, you can ask. Okay, so keep in mind, always the pressure exerted by liquids or gases or fluids is depends on these things. The height of the liquid column above the point, the density of the liquid, and as well as acceleration due to gravity at that given place. At that given place, what is the acceleration due to gravity will decides the pressure exerted by fluids. If anybody having any doubt, you can ask me. So these are the three factors which will affect the fluid pressure. Then next we will study what is the name of the fluid pressure. So the pressure exerted by the fluid, we used to call it as basically buoyant force, or we used to say buoyancy. So from that, we'll discuss in our next class. I hope you all understand, everybody. Everyone clear? And one more thing I want to say you, in a given depth, please remember, of course, again, I will teach you separately. So for example, if I take at this depth, if you take it, the pressure exerted by liquid at this particular height, it is uniformly distributed in all the directions. Understanding? Suppose if I take this height, now let me take this is P1, this is P2, and this is P3. So where the pressure is greater, guys? Anybody? Where pressure is greater? Everybody. P3 is greater than P1 because height of the column, height of the liquid is here greater. That is the reason here pressure is greater. But if I take at this height, because bottle is a three-dimensional one, if I take in any direction at this point, at this height, the pressure at this column height is always uniformly distributed in all the directions. So that is what we used to call it as Pascal's law. Pascal's law. So if you open in your NCERT also, if you are reading, you'll be finding it. So it is the fluid is transmitted undiminished in all the directions. The pressure exerted in any fluid in a particular height is uniformly distributed. That's what undiminished in all the directions. That is the law we used to call it as. What we used to call? Everybody? Pascal's law. Okay. So that is also we'll discuss. I'll teach you. So this is what is about what is the fluid pressure and how to calculate the fluid pressure. Then tomorrow I will teach you how to measure this fluid pressure. That is what particularly liquid pressure. What is the device we'll use to measure the liquid pressure? Anybody? Liquid pressure. Yes. No, atmospheric pressure barometer. Liquid pressure. Manometer. Liquid pressure is manometer. And then tomorrow I will teach you one new concept called as Boyle's law and then Pascal's law. This is only call it as Pascal's law. Pressure is undiminished in all the directions. That is only call it as Pascal's law. So that Pascal's law and Boyle's law, we will discuss it. And then the very important thing, Barham's press. You might be know if you go to the car washing and all, they will lift our car by pressing with the help of a liquid. Am I right, everybody? Hydraulic. Yes, jockeys. Jockeys is not for normal puncture, Mari. For car washing and all, they will lift it and they will put it on above certain height. Do you remember?
Yes, sir.
Yeah.
Yes, sir.
So that is what we used to call it as actually Barham's press. So one side they will apply the liquid pressure, automatically another side it will rises. So that Barham's pressure also we'll study in our tomorrow's class. So hydraulic press, you might be know hydraulic press and all, everybody. Hydraulic working principle, hydraulic press. So that is all it will
Yes,
be.
sir.
So
Yes,
that is
sir.
what, okay, well, that is also we'll study how it will be working and all. So that's all about the today's class. And if you understand this, then the most important concept for you people, what means for school thing, that is only call it as a upthrust. So upthrust, or also we can call it as a buoyancy. And what is buoyancy? What is the cause of buoyancy? Even for buoyancy also I will teach you formula, and then Archimedes principle. What is the verification of Archimedes principle? That is all the things we'll discuss in our coming classes. And then flotation. Next, what is the relationship between flotation and relative density? These many concepts are there. If it is over, this chapter will be complete. Okay. So with this, I will stop. From here, we'll continue in the tomorrow's class. Thank you, everybody. We'll meet in tomorrow.